time now before the coffee break for what we call the Innovation Award pitch. And for this, to guide us through that, I'd like to ask Peter Lindberg to come up to the stage. He's National Project Coordinator, Chairman for EUREKA. Please.
Okay. Okay, and you can hear me loud and clearly, I hope. So this is the session for the award winners for the EUREKA Innovation Award to do their product pitches. There will be another session this afternoon where they will receive the prizes. But the idea for this session is for them to pitch on their projects, give a very short presence on the essence of their work, and for you to vote for the best pitch. And in order to do so, we have to do some practical things first. So if you take your mobile device and if you go to this web address that you see on the screen, www.govote.at, and then you enter this code, 221313, and then you will be able to vote. And you will be able to give your votes in a scale from 1 to 5. And of course, 5 is if you think it's really, really good. 3 if you think it's okay. And if you don't like it at all, it's 1. Or anything in between. And you will not need to rank them yourself. So if you think that the first one is very good and you give it a 5, then you can give a 5 a second and a third time also, if you like them all very well. It will only be, I mean, it's not a problem. So you don't have to think about ranking them. You just give the vote after you hear the pitch, whatever you think is appropriate, you give the points. So this is the idea. And then we count them all together, and then we will reveal the winner in the session in the afternoon for the award winners. So, and while you're preparing yourself for voting, I'm just going to give you some information regarding the Innovation Award. I mean, the core business really of the EUREKA network is the EUREKA projects, and this is why we want to celebrate the projects in this special EUREKA Innovation Award. And it's not quite an annual award, it's recurrent. So approximately 1.5 to 2 years we have had this award. And the committee for the 2016 award has identified 3 winners that you will be here now in this session. And we have 3 categories. We have the added value category, and this is for projects that especially have demonstrated for the project participants, the project partners, that they have received added value, where you think about, increasing productivity, increasing growth, increasing turnover, employees, really results due to the project. This is the first category. And the second one, it's about competitiveness. And then we look at the competitiveness angle. Have you been able to be more competitive when compared to your competitors on the market due to the project? And the third one, it's really the most innovative one. It's the innovators for the future. And this is really about disruptive innovation, things that can really be a game changer in the society. So these are our 3 categories, but all of them are very innovative, close to market EUREKA projects. But they all have their own style a little bit. And now I hope that you are all ready to have been prepared to give your votes. So now the next thing is that I will going to present the award winners to come up on stage and give their pitching presentations. And there will be a 5-minute pitch. And the challenge here is in a very short time to convey the essence of the project and its benefits. And I should also say now, when we are in the voting process, that for you that are following us remotely, in the web broadcast, you will also be able to vote if you go into this web address and enter the code. So it's not only for the people in the room, it's also for those of us who are following this remotely. And now I would like to welcome the first product up on the stage, and it's the ITEA Diamonds products in the category added value. And I would like to welcome Ina Schifferdecker, Axel Renoch, and Jürgen Grossman to come up on the stage and do your pitch. Excuse us, just a short technical break. And while we wait for this, I just got news from my colleague that some of you have already tried to vote, but we will please wait till you actually hear what you're voting for. But it is good to test the technology, but we'll not count these votes.
I just wonder, how do I get my slides? Oh, okay. Thank you. Good morning, ladies and gentlemen. Let's talk about security. Let's talk about IT security. Let's talk about cybersecurity. Did you ever lose data because your computer or your smartphone has been hijacked? Did you ever lose data because your software was malfunctioning? And do you now wonder why I put those two questions? Well, they are related because 9, I repeat, 9 out of 10 vulnerabilities in software-based systems are caused by software faults. 9 out of 10. Back then, when we started, so that's the smartphone criticality. But it's even worse. It's not only about data that can be lost. It's about real assets. Think about a connected car that is hijacked by an attacker. It's just about the real car, which can be stolen because this remote locking is attacked. Or it's about the lives of the driver and of the pedestrians if the braking system is hijacked. That happened last year to Chrysler. And the story goes on. It's about our industrial production, where a lot of autonomic systems are software-driven. It's about aircrafts. It's about all our urban infrastructures, which turned into critical infrastructures, which are vulnerable potentially because of their software. Or it's about our financial systems, where all the commercial assets could be in view of the attackers. When we did start diamonds back then, it was the fact that most of the vulnerabilities were of easy or mid-sized technical complexity, which could rather easily be fixed by secure software design that was well known already back then, but also quality checked and assured by security testing. However, security testing wasn't well known back then, so it was unclear how to make it effective and efficient. It was not clear when to stop testing because enough quality assurance has been done. So our core idea is about using some of the model-driven techniques for security testing. We do combine risk assessment with modeling so that a more elaborated and systematic analysis of the system under test becomes possible. We did combine recent results in model-based testing and test automation with security testing so that it becomes more effective and efficient. And we do combine the active intrusion in security testing with the non-intrusive passive monitoring in order to security check a software-based system not only in development and pre-deployment, but also in their production environment at runtime. And along that, we developed several new methods and approaches and algorithms, for example, for behavioral fuzzing. We developed numerous innovative tools and services. There have been 3 commercial new products. There have been 3 open source products. There have been 10 product updates. To name a few, there's Racomat for model-based risk analysis, which interrelates risk analysis and security testing results and drives the security testing process. There is Facino, which is an open source fast library, which can be combined with your testing tool, which you have in favor. There is MMT, which is an autonomic monitoring distributed system, which allows us to check the security constraints of distributed systems at runtime. Or there is STIP, which are the security testing improvement profiles, which allow to analyze and improve security testing processes. And we make, in addition to the products and services, this known also to all of you by 8 experience reports from our case studies in 6 different industrial domains, which come along with 11 innovation sheets. We did provide several publications, presentations, 4 book chapters, 4 journal articles, 100 other presentations and publications, and we contributed a lot to standardization, in particular to ETSI, but also to ITU and ISO. And again, to name a few, at ETSI, we developed a security testing glossary and a security testing methodology, which was published only January this year. We did provide at ITU an extension of the test automation technology, TTCM3, for security testing and fast testing. And at ISO, we contributed to security indicators which help to assess the system security at runtime. Let me sum up, and I have another good news for you. As of today, the vulnerabilities of software-based systems diminish. In fact, there are lower, easy and mid-sized technical vulnerabilities in the software. That is, of course, a result of many efforts all over the world, no question. However, Diamonds did contribute its bit and put forward the ground for innovative, very advanced and efficient security testing in European industry. And another good news is that it really helps to provide trustworthy, secure and reliable systems, which we all need in the ever-increasing connectivity in the world. So I remain to say, may the diamonds be with you. And I say this not only for the women, but to all of us, because we do need trustworthy, secure systems. Thank you very much.
Okay, thank you very much for the ITR Diamonds project. And I would just like to say that those of you who gave your votes a little bit too early before the pitch, you will be able to vote again. So if you did vote before the pitch, please come back and vote again. And I will also say that for some reason, if you don't have the time to vote, you can also do it during the coffee break afterwards. So now we will continue with the next award winner and the pitching candidate. So I would like to present now Rob van den Brick, and he's representing the award-winning Celtic Plus HFCC GFAST project in the category competitiveness.
Hello everybody, my name is not Brick but Brink, and I'm from the Netherlands, and I work in a research institute called TNO, but I also work together with a whole bunch of industrial partners in Europe. That's why you see so many of those logos. And we are a consortium, and we call ourselves the 4GBB Consortium. And this consortium is a mixture of vendors, telecom operators, and research institutes. And the reason that we are a consortium is that we have a common goal. We want to bring gigabit broadband to everyone. Gigabit broadband to everyone. What does it mean? Well, at first it means gigabit. That means we want to give the people an internet connection with speeds up to 1 gigabit. If you see it today, it's different for every country, but if I speak for the Netherlands, you can get subscriptions to 100, it's occasionally even 200 megabit, but that doesn't mean that we have 200 megabit in the Netherlands. If you look at the majority of the Netherlands, it's maybe 20, 30 megabit. It's less in other countries, it's higher in other countries, it's a matter where you are. So gigabit itself is not the full reason why we get the award, because you can buy equipment that is doing it for you. Okay, it's gigabit to everyone. Is that something value for an award? Well, to everyone, that means I'm not satisfied if 20% of the nation has broadband access. I want something like 90, 95%. Okay, that's more challenging. But that's not worth an award. If you all give me plenty of money, I can make it happen all over Europe and somebody else will do it elsewhere. So it's quite a lot of money to make it happen. That's possible. That's not why we get the award. But before you give me the money, you shall ask me one question. When will I get it? Will it be in 50 years or will it be in 5 years or something in between? And now you're talking. That is exactly what we are aiming to do. We want to accelerate it, that you get gigabit to everyone, 95% coverage, and to accelerate everything. So the most obvious way to bring a gigabit is using fiber. It's a good technology, it's mature. It looks as follows. You have a central location with fiber optic equipment. You have a bundle of fibers going to the houses. And it fans out to the houses, near the houses. And those cables, on the left you see a cable with 100 fibers in it. And on the right you see if you have many of those cables, put it in the ground, works fantastic. So that's the way to get a gigabit. It works even so good that it's already happening. This is an example of the Netherlands. We are digging everywhere to make it happen. And today we have about 10% of this solution. It works okay, but it has one thing in common. These are villages and suburbs where we have the low-hanging fruit. But hey, I want 95%. I'm not interested in 10%. I want 95%. And most people do not live in suburbs, they live in the dense city areas. And if I want to bring it in the dense city areas, then this is the story. I have to do the digging here, the drilling. I have to disturb a lot of people to make it happen. I have to ask licenses from the community to make it happen. And that's why it will not happen in 5 years. That's why if you try to do it in this, it takes you probably 50 years before everything has it. Or maybe longer. Or maybe never. So the first question we are raising ourselves is, why shall we put full fiber everywhere? It's a good solution, but why everywhere? Because the digging and the installation time and to disturb customers, that is exactly the reason that it might be not the good solution everywhere. But the real challenges are not in the fiber, but in the last drop. There's so much digging, so much installation in that part. If you do that in a more clever way, you can gain a lot. The whole trick that we can do is, why not reusing the old telephony cables that are already in the ground? You see a picture at the bottom. That's a telephony cable. Some of them are 100 years old. And they have even up to 900 wire pairs sometimes. And this is probably one with 100 wire pairs, or I don't know exactly. So each wire pair should carry a gigabit. And that 100 times. Is that possible? Today we do it already. Today it's quite common to go up to 100 megabits for a technology called VDSL, but 1 gigabit, is that feasible? Okay. That is exactly the crazy idea we had in 2009. By that time, we had absolutely no idea if this is technically feasible. Because it means that you have signals of 100 megahertz, maybe 200 megahertz going through that telephony cable over a certain distance. So we founded the 4GBB consortium. And since then we have worked hard. We did measurements. We made calculations. We went to the Broadband Forum, a big industry forum on this, and presented our ideas after 2 years. So we got the industry worldwide into movement. And they were so excited, they went to ITU and started asking them, can you make a standard out of this idea? And just only 6 years later, we managed to have an approved worldwide standard on this. And from this consortium, to make it happen, we created more than 300 contributions. And the rest comes from other industry. We also had a silicon, the first products, the prototypes. We have field trials to find out that it really works in only 6 years. And now we have the systems. And today we also have announcements from operators to really deploy this. BT is one of the front runners, British Telecom in the United Kingdom. They start this year rolling out, and others will follow. And we also have a market forecast. The expectation in the United Kingdom is that they have 10 million lines in only 4 years, and then it will grow on. So that promise of that 5 year makes sense. There's a worldwide market predicted by financial analysts. The worldwide market starts at about $5 billion, and that is 2020, and it go on. So we really accelerated with the 4GBB solution, 95% coverage of gigabit broadband. And it's a very good enabler for smart cities. Thank you very much.
Okay, thank you very much, Rob, for this nice presentation of the Celtic Plus HFCC GFAST project in the category competitiveness. And now it's the time to give your votes for this project. And while you do this, I will start to present the last of our pitching contender, and that this is the award-winning Eurostars project, Optobrain, and the category is Innovators of Tomorrow. And so I would like to introduce Emanuela Keller to do the pitch.
Thank you very much. Dear ladies and gentlemen, so I initiated and coordinated the project Optobrain, but moreover, I'm a clinician, I'm a specialist in neurocritical care medicine, and our target is to avoid secondary brain damage, which is mostly due to oxygen deficiency and low brain perfusion. So I realized in the last 20 years that especially in sedated, consciousless patients, we need more sophisticated monitoring techniques. The most important parameter, brain blood flow and oxygen content, they are our surrogate parameters for treatment, but up to now we do not have any monitoring methods available directly at the bedside. With this picture you might have an impression how difficult it is, nearly impossible, to transport these unstable patients, for example, to magnetic resonance imaging units. Our solution was light, so we applied near-infrared spectroscopy and we invented a dye dilution mode for cerebral blood flow measurement. The second invention was a probe. So a probe for intracranial pressure measurement, we needed anyway neurosurgical intensive care medicine. So patients with severe traumatic brain injury, severe bleedings or stroke, they have the development of brain edema and they have intracranial hypertension, a high pressure in the skull, and therefore we have to treat them with an ICP, an intracranial pressure probe. So what we did, we took a conventional ICP probe and we put some fiber optics into that probe to measure directly oxygen and blood flow in the white matter of the brain tissue. So there was 15 years of research together with the Technical University in Zurich and the neurocritical care unit of the University Hospital, and we developed some scientific prototypes. And OptoBrain made it possible finally to develop the final product. So with our spin-off company Nemo Devices, it was possible to finalize the smallest cerebral near-infrared spectroscopy instrument ever constructed in the world. As well, we developed the small ICP probe, which not only measured intracranial pressure, temperature, oxygen supply, oxygen metabolism, and brain blood flow, but was just for the neurosurgeon exactly the same device as a conventional ICP probe. Furthermore, together with the company Creaholic, it was possible to develop or finalize a strictly non-invasive plaster-based patch. Up to 6 patches can be attached over the skin. And finally, with the German company UseLab, it was possible to finalize a very user-friendly graphical user interface. The clinical partners, they did measurements in a clinical study, so the clinical data finally, as well as all the documents, were sufficient to achieve the major milestone of the OptoBrain, which was the CE mark, which we got in July 2014. And furthermore, it was possible to add new patents to our patent family together with Creaholic. So thank you very much. Thank you Eurostars. Thank you all the partners in the project. Thank you for the medical staff which supported us in the clinical study. And last but not least to the patients. And I think we could go a major step forward to improve the outcome of TBI patients and stroke patients. Thank you.
So, thank you very much, Emanuela, and the OptoBrain project. And now you have the possibility to vote for this, the last of the product pitches. And while you do that, I will just tell you a few words about what happens next. Because now, of course, we will go back and we will count your votes. And then we will have a result for you this afternoon that will be presented in the award session, where also these projects that have done the pitches now, they will receive their EUREKA Innovation Awards. And this session will occur in 4:15 in the afternoon. So, thank you for being present and helping us with the voting procedure. And thank you also to these 3 projects for their very nice product pitches. I really think that we got the essence of their product ideas. So this concludes the pitching session, and welcome back for the award session this afternoon. Thank you.
Thanks a lot, Peter.